Welcome back to the Deep Dive, where we deep dive into the latest AI and machine learning research.
That's right.
And today we're taking a look at a batch of papers mostly published on Tuesday, March 18th, 2025 on arXiv.org.
Yeah, we're going to see what's new in the world of AI.
So what are some of the big takeaways from today's research?
Well, it looks like a lot of researchers are really focused on making AI models more efficient, making them faster, less expensive to run, things like that.
That makes sense. AI can be pretty resource intensive, especially as models get more complex.
Exactly. So finding ways to streamline those models is super important if we want to see AI used more widely.
So where do we start? What's the first paper that caught your eye?
There's one called Nonlinear Principal Component Analysis with Random Bernoulli Features for Process Monitoring. It's a mouthful, I know.
Okay, break it down for me. What's it all about?
Sure. So imagine you're monitoring a complex system, like a manufacturing plant, right? You've got tons of sensors collecting data all the time.
And you need to analyze that data to make sure everything's running smoothly.
Exactly. And you need to do it in real time so you can catch problems before they become serious. But the calculations involved can be very computationally expensive, especially when you're dealing with large data sets.
So this paper is proposing a more efficient way to do those calculations.
Right. They're using something called random Bernoulli principal component analysis. Basically, it's a way to approximate those complex calculations without sacrificing too much accuracy.
Kind of like finding a shortcut.
Yeah, kind of. Yeah, and the best part is they've actually proven mathematically that this approximation is reliable. Plus, they've shown that it can significantly reduce computational complexity in real-world tests.
So this could have a big impact on how we monitor all sorts of industrial processes, potentially making things much cheaper and faster.
Exactly.
Okay, what else is going on in the world of efficient AI?
Well, there's another paper called Convergence Analysis of Alpha SVRG under Strong Convexity. Now, this one's getting into the nitty-gritty of how AI models learn from data.
All right, take me there.
So a lot of machine learning algorithms use what are called stochastic first-order methods. These methods are pretty efficient, but they can be a bit noisy.
Noisy.
Yeah, they introduce a certain amount of randomness into the learning process. It's like trying to listen to a podcast in a noisy room. You can still hear it, but there's all this background noise that makes it harder to understand.
I get it. So what's the solution?
This paper is looking at a technique called Alpha SVRG, which is specifically designed to reduce that noise.
To help the AI model learn more clearly, so to speak.
Yeah, exactly. And the research provides a really in-depth mathematical analysis of how quickly and reliably Alpha SVRG can learn, especially for a certain type of problem known as strongly convex.
I'll trust you on the technical details there, but what's the big takeaway?
Basically, they've shown that Alpha SVRG has the potential to learn faster than some other popular methods under the right conditions. And that could lead to more efficient and faster training AI models.
That's always a good thing.
Absolutely.
Okay, anything else on the efficiency front?
Oh, there's one more I wanted to mention. This one's about privacy-preserving AI, which is a huge area of research these days.
Yeah, especially with all the concerns about data security and how AI is being used.
Right. This paper is called Federated Cubic Regularized Newton Learning with Sparsification Amplified Differential Privacy.
Okay, let me guess. It's about training AI models on sensitive data without compromising privacy.
You got it. Specifically, it's about federated learning, where you train a model on data that's distributed across multiple devices without actually bringing all that data together in one place.
So, like, if you wanted to train an AI on health data from people's smartphones, you wouldn't have to collect all that data on a central server, which could raise all sorts of privacy concerns.
Precisely. And this new algorithm they've developed, DPFCRN, uses a combination of techniques to protect privacy and make the learning process more efficient.
What kind of techniques?
Well, they use something called differential privacy, which basically involves adding a bit of carefully calibrated noise to the data updates that are shared between devices.
So you're making it harder to identify individual data points while still allowing the model to learn effectively.
Exactly. And they also use a technique called sparsification, which means only the most important updates are transmitted between devices.
Okay, so that's about making the communication more efficient.
Right. And here's the really interesting part. They've actually shown that this sparsification can also make the privacy guarantees even stronger.
So you're killing two birds with one stone, better efficiency and better privacy.
Exactly. It's a really elegant solution.
That's impressive. Okay, we've talked a lot about efficiency. What else is new in AI research?
Well, there's a lot happening in the world of generative AI. Those AI systems that can create new images, text, music, and so on.
Right. We've seen some amazing examples of that lately.
Yeah, and the technology just keeps getting better. There's a paper called Platis, Pushing the Limits of Attention and Diffusion Models at Inference Time by Leveraging Sparsity. This one's about making those generative models even better at what they do.
Okay, so what's the key insight here?
Well, it focuses on something called the attention mechanism in these models.
Attention.
Yeah, it's basically how the model figures out which parts of the data are most relevant to the task at hand. Like if you're generating an image of a cat, the attention mechanism helps the model focus on the parts of the data that are most important for generating a cat-like image.
So it's like giving the AI laser focus.
Exactly. And what Platis does is it uses a more efficient form of attention during the generation process.
Making it faster and less resource intensive.
Right. And the cool thing is they've shown that this actually improves the quality of the generated content.
So the images or text the AI creates are actually better?
Yeah. They tend to be more aligned with the user's input, and human evaluators generally prefer them.
So it's a win-win. Better quality and better efficiency. That's pretty impressive.
It is, and it shows how much potential there still is for improving these generative models.
Now let's switch gears a bit. What's happening in the area of human-AI interaction and decision-making?
Well, there's a fascinating paper called Conformal Prediction in Human Decision-Making. This one's all about dealing with uncertainty in AI predictions.
Uncertainty.
Yeah. In a lot of real-world applications, it's not enough for an AI to just give you a single answer. You also need to know how confident it is in that answer.
Like if an AI is helping a doctor make a diagnosis, you want to know if it's 99% sure or only 50% sure.
Exactly. And conformal prediction is a method for quantifying that uncertainty. Instead of just giving you a single answer, it gives you a set of possible answers, along with a measure of how likely each answer is.
So it's like saying, here are 3 possible diagnoses, and we're 80% confident that the correct one is in this set.
Right. But this paper goes deeper than that. It actually explores how useful these prediction sets are for human decision makers.
Meaning, do people actually make better decisions when they're given this information about uncertainty?
That's the question. And it turns out the answer is not so simple. The way humans interpret and use this information is complex. It depends on a lot of factors, like the person's goals, their experience, the context of the decision, and so on.
So just providing more information doesn't necessarily lead to better decisions. You have to think carefully about how that information is presented and how people are likely to use it.
Exactly, and that's one of the key takeaways from this research. It highlights the need for more research on how to present AI predictions in a way that truly supports human decision-making.
It's about bridging the gap between the technical capabilities of AI and the cognitive processes of humans.
Right. We need to make sure that AI is actually helping people make better decisions, not just making them more confused.
Okay, let's get back to generative AI. What else is new in that area?
There's a lot of interesting work being done on how AI learns the underlying structure of data. Like, how does an AI learn the rules of grammar so it can generate grammatically correct sentences?
Right, or how does it learn the visual patterns that make a cat look like a cat?
Exactly. There's a paper called How Compositional Generalization and Creativity Improve as Diffusion Models Are Trained. It looks specifically at how diffusion models, which are behind many of the most impressive generative AI systems, learn these rules of composition.
So what have they found?
Well, they used a theoretical approach based on simplified models of this hierarchical structure in data. And what they found is that diffusion models seem to learn these rules in stages.
Stages.
Yeah, they start by learning simpler, lower-level patterns, and then they gradually build up to understanding more complex, higher-level structures.
Kind of like how kids learn language. They start with simple words, then they learn how to put words together into phrases, and eventually they can write whole stories.
That's a good analogy.
Yeah.
And what's really interesting is that this process of learning these compositional rules seems to be directly related to how much data the model is trained on.
So the more data you feed it, the better it gets at understanding the underlying structure of that data.
Exactly. And that leads to more coherent and creative outputs. They've seen this in their experiments with both text and image generation.
That makes sense. It's like anything else. The more you practice, the better you get.
Right. And that's why we're seeing such rapid progress in generative AI. The models are getting better and better as they're trained on larger and larger data sets.
What other exciting developments are there in generative AI?
Well, generating realistic 3D scenes has always been a big challenge. Creating virtual worlds that look and feel convincing.
Yeah, it's a lot more complex than just generating 2D images.
Right. But there's a paper called Generative Gaussian Splatting. Generating 3D scenes with video diffusion priors, that offers a really promising new approach.
Tell me more.
So they call their technique generative Gaussian splatting, or GGS for short. And it combines the strengths of 3D representations with the power of those pre-trained video generation models we were talking about earlier.
Okay, how does that work?
Well, they represent a 3D scene as a collection of tiny 3D blobs with certain features attached to them. Then, they use a video generation model to figure out how those blobs should be arranged to create a coherent and realistic scene.
So it's like the video generation model is imagining how those 3D blobs would move and interact in a real-world scene.
Yeah, that's a good way to think about it. And once they have that information, they can use it to render the scene from different viewpoints or even reconstruct a full 3D model.
And how does it compare to other 3D generation techniques?
Well, their evaluations show that GGS produces significantly better results in terms of consistency and realism.
So the 3D scenes it creates are more believable and less likely to have weird glitches or inconsistencies.
Exactly. And that's a big step forward in 3D generative AI.
Okay, what else is happening in the world of generative AI?
Well, personalization is another big area of research. How do you generate images or text that's specifically tailored to an individual's preferences or needs?
Right, like creating a portrait of your pet or generating a story with you as the main character.
Exactly. And there's a paper called Personalize Anything for Free with Diffusion Transformer that's making some really interesting progress in this area.
What's their approach?
Well, they focus on a type of generative model called diffusion transformers, or DITs for short. And they've discovered that you can achieve a surprising level of personalization without actually having to retrain the model.
So you don't need to feed it a bunch of new data about the specific person or object you want to personalize.
Right. Instead, they use a technique called token replacement. Basically, they identify certain key components within the DIT model and replace them with components extracted from an image of the target subject.
So if you wanted to generate an image of your dog, you would feed the model an existing photo of your dog, and it would use that information to personalize the generation process.
Exactly. And they've shown that this approach can generate really high-quality personalized images without any additional training.
That's pretty amazing. It opens up a lot of possibilities for creating personalized content.
It does. And it also highlights the flexibility and potential of these diffusion transformer models.
Speaking of flexibility, what's happening in the application of generative AI to specific fields like healthcare?
That's a great question. There's a paper called MedLord, a medical low-resource diffusion model for high-resolution 3D CT image synthesis. This one tackles the challenges of using generative AI in medical imaging.
I imagine there are a lot of challenges there. Medical data is very sensitive, and it can be hard to get large enough data sets to train AI models effectively.
Right. And generating high-resolution 3D medical images, like CT scans, can be very computationally demanding.
So what's MedLord all about?
It's a generative diffusion model that's specifically designed to work in resource-constrained environments, meaning it can generate those high-resolution 3D CT images, even if you don't have a lot of computing power available.
So it's like a lightweight version of a generative model, but it can still produce high-quality results.
Exactly. And they've shown that it actually outperforms other state-of-the-art models when operating under similar limitations.
That's impressive. So this could really expand access to AI-powered medical imaging, especially in areas where resources are limited.
Absolutely. It has the potential to democratize access to these powerful technologies.
Okay, let's move on to some other applications of AI. What's happening in agriculture?
There's a paper called Mitigating Bad Ground Truth in Supervised Machine Learning-Based Crop Classification, a multi-level framework with Sentinel-2 images. This one's about improving the accuracy of crop classification using satellite imagery.
I can see how that would be useful. Knowing what crops are being grown where is essential for all sorts of agricultural planning and management.
Exactly. But the accuracy of these AI models depends heavily on the quality of the training data.
What kind of training data?
Well, you need to have accurate labels for the satellite images. Which areas in the image correspond to which crops. This is called ground truth data.
But getting that ground truth data can be tricky, right? It's not always easy to tell what's growing in a field just by looking at a satellite image.
Right. And there can be errors in the labeling process, or the land use might change over time, which can lead to inconsistencies in the data.
So this paper is proposing a way to clean up that noisy ground truth data.
Exactly. They use a multi-level framework that takes into account how different crops change over time, based on data from Sentinel-2 satellites.
So they're looking at the patterns of growth and change to identify areas where the initial labels might be incorrect.
Right. And they've automated this process so it can be applied to large data sets.
And what kind of impact does this have on the accuracy of crop classification?
Well, they've shown that it can significantly improve the accuracy of standard machine learning models, in some cases by as much as 70%.
Wow, that's huge. So this could lead to much more reliable crop maps, which could have all sorts of benefits for farmers and agricultural planners.
Absolutely. It's a great example of how AI can be used to improve efficiency and sustainability in agriculture.
Okay, what other applications are we seeing?
Well, there's a lot happening in the world of autonomous driving. There's a paper called New Plan Q, a large-scale dataset and benchmark for multi-view driving scene understanding in multimodal large language models. This one's all about helping self-driving cars better understand the complex environments they operate in.
Self-driving cars rely on a lot of sensor data, right?
Yeah.
Cameras, radar, LiDAR, and so on.
Right. And processing all that data to make sense of the driving environment is a huge challenge.
So this paper is introducing a new benchmark to test how well AI models can understand these multisensory driving scenes.
Exactly. They call it New Plan Q A-Evil. And they've also released a massive data set of real-world driving scenarios with associated questions and answers to help train and evaluate these models.
What kind of questions and answers?
Well, things like, what kind of car is in front of us? Or, is it safe to change lanes?
So questions that a human driver would need to be able to answer in order to drive safely.
Right. And the goal is to develop AI models that can answer these questions just as accurately as a human driver.
But this is a challenging task, right? Driving environments are incredibly complex and dynamic.
They are. And that's why this new benchmark and dataset are so important. They provide a standardized way to measure progress in this area and push the boundaries of what AI can do.
So what are the key findings from this research?
Well, they found that models that incorporate a bird's-eye view of the scene tend to perform better. This means they can see the whole driving environment from above, which gives them a more comprehensive understanding of this situation.
Like having a drone's eye view of the road.
Exactly. And this highlights the importance of spatial reasoning for self-driving AI. It's not enough to just recognize individual objects. You also need to understand how those objects are arranged in space and how they're likely to move and interact.
That makes sense. It's like playing chess. You need to see the whole board to make the best moves.
Right. And that's what this research is trying to achieve. Developing AI that can see the whole driving board and make safe and efficient decisions.
What other applications of AI in healthcare are we seeing?
There's a paper called MMLNB, Multimodal Learning for Neuroblastoma Subtyping Classification, assisted with textual description generation. This one focuses on improving the accuracy of diagnosing neuroblastoma, a type of childhood cancer.
So using AI to help doctors make more accurate diagnoses.
Exactly. And specifically, it's about classifying different subtypes of neuroblastoma.
Why is that important?
Well, different subtypes of neuroblastoma respond differently to treatment. So getting the diagnosis right is crucial for choosing the most effective treatment plan.
I understand. So how does this AI model work?
It's a multimodal model, which means it uses both images and text to make its diagnoses.
Okay, break that down for me.
Sure. So it analyzes microscopic images of tuber tissue, just like a human pathologist would, but it also generates textual descriptions of what it sees in those images.
So it's like the AI is writing a report on its findings.
Yeah, kind of. And then it uses both those textual descriptions and the original images to make a more informed and accurate classification of the neuroblastoma subtype.
So it's combining the power of image analysis with the nuance of language understanding.
Exactly. And the results showed that this multimodal approach is significantly more accurate than models that only use images.
That's a big win for AI in healthcare. What other challenges are researchers tackling in the field of AI?
Well, we're seeing a lot of work being done on addressing misinformation and online safety. There's a paper called Online Misinformation Detection in Live Streaming Videos that highlights the growing problem of misinformation spreading through live video platforms.
Live streaming is becoming increasingly popular, and it's definitely a new frontier for misinformation. It's harder to monitor and control than static content like text or images.
Right. And that's why this paper is so important. It clearly defines the problem of online misinformation detection in live streaming and outlines some potential avenues for future research.
So they're not presenting a ready-made solution, but they're laying the groundwork for developing effective AI tools to tackle this problem.
Exactly. It's a call to action for the AI research community to focus on this growing threat.
It sounds like an area ripe for innovation. Okay, what other challenges are AI researchers grappling with?
Well, security is a big one.
Mm-hmm.
Making sure that AI systems are robust and can't be easily manipulated or attacked. There's a paper called Proactive Adversarial Defense, harnessing prompt tuning in vision language models to detect unseen backdoored images, that addresses a very specific security threat called backdoor attacks.
What are backdoor attacks?
Well, imagine you're training an AI model to recognize different objects, like cars, bikes, and pedestrians.
Okay, I'm imagining that.
Now, imagine that someone maliciously inserts a hidden trigger into the training data. Maybe it's a specific pattern of pixels or a certain sound or even a particular word.
And this trigger is designed to make the AI model misbehave in a specific way.
Exactly. So the model might perform perfectly normally most of the time, but when it encounters that trigger, it will suddenly make a wrong prediction.
That sounds dangerous. Like, if it's a self-driving car AI and the trigger is a certain sticker on a stop sign, the car might just drive right through the intersection.
Exactly. And the scary part is that these backdoor attacks can be very difficult to detect. The trigger might be so subtle that it's practically invisible to a human observer.
So this paper is proposing a way to detect these backdoored models.
Right. They use a technique called prompt tuning in vision language models.
What's prompt tuning?
Well, it's basically a way to train small, adaptable text prompts that can effectively distinguish between outputs from clean and backdoored models.
So they're training the AI to recognize the subtle signs of a backdoor attack, even if the specific trigger is unknown.
Exactly. And their results are really promising. They've shown that they can detect these unseen backdoor triggers with a high degree of accuracy.
That's a big step forward in securing AI systems. What other challenges are keeping AI researchers up at night?
Well, bias is a big one.
Yeah.
Making sure that AI systems don't perpetuate or amplify existing societal biases.
That's crucial. We've seen a lot of examples of AI systems exhibiting biased behavior, and that can have serious consequences.
Absolutely. And there's a paper called No LLM is Free from Bias, a comprehensive study of bias evaluation in large language models that takes a really deep dive into this issue.
What did they find?
Well, they evaluated a range of large language models, LLMs, using a variety of techniques to probe for different types of bias.
What kind of biases?
Things like biases related to gender, race, ethnicity, religion, sexual orientation, and so on.
And did they find any biases?
Unfortunately, yes. They found that all the LLMs they tested exhibited some form of bias, although the extent and nature of the biases varied between models.
So even the most advanced AI systems are still susceptible to these biases.
It seems so. And that's a real concern. It means we need to be very careful about how we develop and deploy these systems. We need to make sure that they're fair, equitable, and don't discriminate against certain groups of people.
It's a reminder that AI is a tool, and like any tool, it can be used for good or bad. It's up to us to make sure that it's used responsibly and ethically.
Absolutely. And that requires ongoing research and development, as well as thoughtful discussions about the societal impact of AI.
Okay, one last topic before we wrap up. What's happening in the area of machine unlearning?
Well, there's a paper called Towards Robust and Parameter-Efficient Knowledge Unlearning for LLMs that tackles this challenge head-on.
Machine unlearning, what's that?
Basically, it's the ability to remove specific information from an AI model without having to retrain the entire model from scratch.
Why would you want to do that?
Well, there are a lot of reasons. Maybe the data used to train the model was inaccurate or biased, and you want to remove that influence. Or maybe the model learned something that's now considered sensitive or confidential, and you need to forget that information for privacy reasons.
So it's like giving an AI a selective memory wipe.
Yeah, kind of. And this paper focuses on making that process more efficient and reliable.
How so?
Well, they've developed new techniques that allow you to remove specific knowledge from an LLM without significantly impacting its overall performance.
So you can erase the unwanted information without breaking the AI.
Exactly, and that's a big step forward in machine unlearning. It means we can start to think about using AI in more sensitive applications, knowing that we have the tools to control what it learns and what it forgets.
That's pretty remarkable. It seems like we're making progress on a lot of fronts in AI research.
We are. It's a really exciting time to be following this field.
Well, that's all the time we have for today. Thank you for joining us on the Deep Dive.
It's been a pleasure.
And we'll be back tomorrow with more news from the cutting edge of AI.